Hi students, welcome to another video tutorial. This week we'll be talking about the repetition programming structure. So earlier we talked about sequential programming is where you have one line of code executed right after the other, after the other, after the other. So they're all executed sequentially. And then last week we talked about conditional programming where you have a code that executes depending on whether or not a condition has been met. In other words, you perform a test, and if that test has been met, then you execute the code. Well, this week we're probably going to talk about the most powerful of the four structures, and that's the repetition structure. And once you understand and master the repetition structure, you'll find that you can write much more powerful programs. The repetition structure basically involves executing a set of several lines of code multiple times. And the number of times it's executed depends on whether or not a condition has been met. So this differs from, say, for instance, the conditional programming structure where the code can be executed one time depending on whether or not a condition has been met. With repetition structure, it can be executed several times or multiple times until a certain condition has been met. There are two fundamentally different types of repetition. There's pre-test and post-test repetition. With pre-test repetition, what happens is the condition is checked before you even begin to run the code. So, your program's working, it gets to the repetition part of the program, and it checks to see if the condition has been met. And theoretically, there are instances with pre-test repetition where you may not execute the code at all. If you get to the line of code that begins the repetition where the first test is performed and the condition has already been met, then in theory that code will never be executed. With the post-test style of repetition, what happens is the code is performed one time, and then at the end of the repetition it tests it again. And at that point, if the test passes and the condition has been met, then the execution will be stopped. But what that means is that with post-test repetition, the code is executed at least once, no matter what. With post-test repetition, if you may have a situation where it runs the code, gets to the end, performs the test, and if the condition has not been met, then it will go through and perform it again and check and see if it's been met after that time, and it will continue to perform the code until the condition has been met. Generally, the fundamental difference between pre-test and post-test loops or pre-test and post-test repetition is that pre-test can theoretically does not have to be performed, whereas with post-test it's going to be performed at least once. Another situation you'll find is that post-test loops are generally going to be executed at least one more time than pre-test loops. So for instance, if you set up the exact same structure with a pre-test loop, and say, for instance, it executes 5 times, for example, well, with a post-test loop, what you'll see is it will execute 6 times. It will execute one extra time, depending on what the condition is. Generally, it's my preference to use pre-test loops wherever is possible, and most of the books I read and most of the programs I've seen that have been developed usually use pre-test loops exclusively, and that's what we'll do in this class, although I will demonstrate one post-test loop for you. Okay. And notice I've been using this term loop, and I haven't really described it yet. Loop or looping is another word for repetition. Okay. So generally, I will probably use the term looping. Okay. The code loops however many times it needs to until the programming condition has been met, whatever condition you specify. There are 3 types of loops. There's the for loop, the while loop, and the do while loop. The for and the while loop, they are pre-test loops. The do while loop is a post-test loop. So let's begin. And I'm going to do these in slightly different order than I have them in the notes, but I'm going to do the for loop first. You'll notice that I've declared a variable called loop count. That's going to keep a count on how many times the loop has been executed. So that's just kind of a variable, like kind of a dummy variable that we always set up when we're doing loops. And basically its sole goal in life is just to keep a count on how many times the loop has been executed. So what I've done is I've set up a very basic for loop. And what's different about the for loop than the other two types of loop is there in the initial statement that starts the loop, you perform the 3 steps of looping all on one line of code. Whereas in the other two types of loops, you do it throughout the loop. You do it at different points in the loop. With the for loop, you do it at the beginning. So all the stuff you need to do is done at the beginning. So for instance, the first thing you always do with the loop is you initialize the counter. Okay, so you start out and you say loop count equals 1. So you're starting the loop count at 1. It will begin with 1. So 1 is currently stored in the loop count variable. The second thing you'll always do with the loop is you'll specify a condition, and the loop will be performed until that condition is met. So this particular loop will be performed until the loop count, while the loop count is less than or equal to 5. So if the loop count variable is set to 1, 2, 3, 4, or 5, the loop count will be executed. But once the loop count gets to 6, that violates the condition that we've set up, and the execution of the loop will stop. And the execution of the loop ends with this second bracket. So everything within these 2 brackets is considered to be part of the loop. And once the code or once the compiler gets to this second closing bracket, that will end the execution of the loop. The third thing we always do with our loops is we increment them. Okay, we increment them. So every time the loop is executed, every time that closing bracket is reached, 1 is going to be added to the previous loop count total. So for instance, if the loop gets to that second bracket and the loop count is set to 3, 1 will be added to it, and now the loop count will be equal to 4. If the loop count's 4, it gets to the end of the execution, it adds 1 to it, and then the loop count is equal to 5, and so on and so forth. Now I'm just going to set up a very simple loop. It's not a particularly useful loop, but hopefully it'll demonstrate what it is that a loop does. Okay, so this particular code, what it will do is every time it runs through the loop, it will say, this is printed due to 1 pass through the loop, so it's letting us know that the loop has been executed 1 time, and then it will give us the current value of the loop counter. Okay, so it says the loop count is currently set to %d. Remember, that's the integer control string, and then whatever the current value of the loop count variable will replace that. So if the loop count is at, say for instance, at 2, then the number 2 will be there. Another thing I'm going to do, and this is not required of loops, in fact you don't want to do this in a functional program, but for instructional purposes, what I like to do is once the loop is over, I like to type a line of code that lets us know that the loop has been completed, and then lets us know the current value of the loop counter. Okay. So hopefully what we'll see here, because we did initialize the variable at 1, we set a condition that says this loop is to be executed while the loop counter is less than or equal to 5, and each time through the loop it's going to add 1 to the old value of the loop counter. So hopefully what's going to happen is that this particular loop is going to be executed 5 times. It's going to be executed while the loop count is set to 1, then 2, then 3, then 4, and then 5. And then once the loop count is incremented up to 6, it violates the condition because it's greater than 5. That will end execution of the loop, and that particular run of the loop will not be executed because the loop count's too high, and then it will go down here after the loop and tell us that the loop count is 6. So let's see how that looks. Got to save. Should have saved it before I started, but all I'm doing is just a simple save. And that's what we see. We see that the loop count, or the statements within the loop, are printed 5 times. It's printed up here when the loop count is equal to 1. It's printed here when the loop count is equal to 2. It's printed here while the loop count is equal to 3. It's printed here while the loop count is equal to 4. And then it's printed here while the loop count is equal to 5. Once the fifth time through the loop count is incremented to 6. And then when it does its pre-test to see if it needs to execute the loop again, it finds that it's too high and violates the condition, and the loop is not executed the 6th time through. So then the loop execution closes, and then it goes down and does that very last line of code that says the loop count variable is 6, which is too high and it violates the condition that we set up in the beginning of the for loop. So for instance, if we change this to 10, you see the loop is executed 10 times, and then once the loop count gets to 11, then that violates the condition, and the loop isn't executed the 11th time through the code. Now you remember I also mentioned the fact that pre-test loops such as the for loop can theoretically not be executed at all. So let's just do something crazy and set our condition so that the loop count executes every time through the loop that the loop count is less than or equal to 0. Well, in this particular instance, what we see is the loop count has been initialized to 1, so it starts at 1, which means the very first time through the loop, the condition is already violated because the loop count is greater than 0. So what we should see here is that the loop is never executed at all. And there you see the loop was never executed. It did the pre-test, found out that the condition was invalid because 1 is greater than 0. And then it moved directly down here and printed this line of code that tells us that the loop has been completed, even though in this instance it never ran even the 1 time, and that the loop count variable is set to 1. for loops are good loops. I'm generally don't use for loops too much. I generally use while loops, and that's the second type of loop. Okay. So with while loops, what we do is instead of using the word for at the beginning, we use while. And then in parentheses, all we do is put the condition. So we're not initializing nor are we incrementing the loop count within the while statement. So that's what differentiates it from the for statement. With while statements, what we do is we we initialize the loop count before we even enter the while loop. So we go up above the while loop and initialize it. And then within the while loop at the end of it, it'd be the very last thing you do in the loop. That's where we increment it. Okay, and this time, just for example, we'll see if we can make it run 10 times. Okay, so we initialize it before the loop begins, we set the condition within the while statement, and then we increment it at the end of the while statement, or at the end of the while loop. So we're not doing it on all on one line like we did with the for loop. We're going to do it on 3 different lines. And that's what we see. It works exactly like the for loop. There's no differences in the way they work. They're just different in the way you set them up. Okay, so we see that this particular loop executed 10 times. So it executed while the loop count was less than or equal to 10, and that ended up being 10 times. And then once the loop was complete, at that point the loop count variable was set to 11, which violated the condition, so the loop wasn't executed on the 11th time through, and it went down to that last line of code that said that the loop was complete. And that's probably, pretty much, in the notes, once I laid out the 3 types of loops, pretty much everything I did after that was done with the while loop, because that's the type of loop I use. If you like the for loop better in your code, you can use it. It's a perfectly good looping structure. It's just I'm used to using while, and for the sake of simplicity, it didn't seem worthwhile to set up all these different programming examples and doing them with both types of loops. So most of the programming examples in your notes, I just use a while loop because that's the one I like to use, and it just would have made the notes twice as long to do everything with a for loop and a while loop. Another thing I want you to be aware of is that your incrementation statement right here, you don't always have to increment by 1. Now, generally you'll want to. But, for instance, you could increment it by 2 if you desire to do that. Okay. So what happens with this particular example is within the while loop, the incrementation statement is going to add 2 to the old value of the loop count every time through instead of just the 1. So let's see how that executes. And you see that this time the loop doesn't run as many times as it did in the old example, because each time through the loop we're incrementing by twice as much. So it goes from 1 to 3 to 5 to 7 to 9. And then there is no 10 because we're adding 2 to 9. So the last time through the loop count is set to 11, which means that the loop isn't executed when it's at 11. So, you can use different values for your loop count. You can use different values for your incrementation statement. just lay out another crazy example, and I'm thinking of this off the top of my head, so I hope it works. But you can even use decreasing incrementation statements. So in this particular example, you could set the loop count and initialize it at 10, and then set it so that the while loop executes while the counter is greater than or equal to 0, and then each time through the loop you subtract 1 from the loop count, so you're going 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So this would be a decreasing loop. It would decrease each time through. Okay. So we start with 10, and then each time through the loop it takes 1 away until eventually the condition is violated when the loop count is less than 0. So when it gets to -1, the loop isn't executed. Okay, so let me set my parameters back to where I started, because generally we don't use decreasing loops. I just wanted to show it to you to further your understanding of how these loops work. The third type of looping structure is what we call the do-while loop, and it's a post-test loop. In other words, the condition isn't tested. The condition isn't tested until the end of the loop. So with do-while loops, the condition isn't tested until the end of the loop. So you go through, and the first thing it does is tells you to do something. It doesn't even perform a test the first time through. It just goes directly into it and does it. Then it increments the loop count, and then it tests to see if the condition has been met. We'll do something smaller this time. We'll just do 3. Just for the sake of example. Oops. Do-while loops apparently have to have a semicolon at the end. I'm sorry, but so at the end of the while condition there, at the end of the parentheses, put a semicolon, and that'll terminate the execution. What you see is that with the do-while loop, what it does is it goes through the first time, and at this point the loop counter is set to 1. It doesn't even perform a test, so it performs these 2 lines of code no matter what. Okay. Then it adds 1 to the loop count, so the loop count now equals 2. It goes back to the top of the loop execution, performs these 2 lines of code and prints them to the screen, then adds 1 more to it, so now it's equal to 3. It tests the loop count and says 3 is less than or equal to 3, which is true. Then it goes back up here and does a do. Okay, and then it runs back through there. Now you remember earlier I told you a post-test loop will be executed at least once no matter what. I just paused the video just a second because I wanted to test something off camera. So here's a situation where we have specified the execution of this loop depending on the loop count being less than or equal to 0. So in theory, this loop really should never execute, and if it were a pretest loop, it wouldn't, because the loop count starts out at 1, which is already greater than 0. And remember, it's got to be less than or equal to 0. But notice what happens when I run this code. See, notice that the first time through the loop, it prints it. It said, even though the loop count is not less than or equal to 0, it's 1, it still actually performs the code within the loop, and that's not what we want to happen. Okay? And then when the second time through the loop, the test is violated, and at that point, it'll stop execution. And the reason it does this is right now the loop count is equal to 1, which we already know violates the condition. But notice once it enters the loop, it prints these two statements to the screen before it even tests to see if the condition has been met. So like I was telling you, with a post-test loop, it's going to be executed one time no matter what. I could have set this loop count equal to 1,000, which would clearly violate the condition. And you still see that it performs the code within the loop the one time. Okay. So to me, post-test loops, or in other words, the do-while loop, is not very useful. I guess there are instances where it would be useful, but offhand, off the top of my head, I can't really think of one. So pretty much in this class, we'll always use pretest loops, okay? And pretty much we'll always use the while loop. Not because it's really better than the for loop, it's just the one I happen to like to do better. And if you like the for loop better, feel free to use that. So that's going to end this first set of video tutorials for the week. In the second video tutorial for the week, I'm going to talk about how to do running totals with loops, and that's really, really useful. And we'll go back to this particular concept time and time and time again, okay? Because that really lets you do some really interesting things with your programs. You'll notice we're only in the 4th week of class, and we've already gotten progressively more difficult. And the one thing I would encourage you guys as students to do is when you read through these notes and you go through them, you'll notice I break them down virtually one line at a time. And that's what you have to do to understand these programs. You can't read a program like you would a book. You can't read it a page at a time and then try to you can't read it a page at a time and then try to understand it. Programs must be understood one line at a time. You read one line and think about what is it that line is doing. You figure out what that line does, you go to the next line, and you say, what is it that line is doing? Then you go to the next line and say, what is it that line does? And you just have to do it a line at a time. There is no quick way to do it. It's got to be one line at a time. And particularly with these repetition statements where you have the loop count set to a different value each time through the code, sometimes you have to go through a line within a repetition structure, and you have to go through it multiple times. So for instance, if we had a repetition structure that was set to run while the loop count was less than or equal to 5, you really need to go through the loop each of the 5 times in your head and think about what is it that the loop count is set to? What is it that's being tested? What is the condition, in other words? And then what is it that I'm incrementing it to for the next time through the loop? And that's the only way to understand it. There is no quick way to understand it. It's got to be done a line at a time, and in the instance of the repetition statements, it's got to be done, each line has to be thought about several times. So I'm going to go ahead and shut down the recorder for this particular video tutorial, and then I'll start another one, and that one will be dealing with running totals.